Welcome to Inverse of Radical Functions. Let's start. So we have 4 essential questions that we want to be able to answer today. What is the inverse of a radical function? What are the steps for finding the inverse? What restriction does the inverse of a radical function need? And then how do we prove that the two functions are inverses? So we're going to be able to answer all 4 of these by the end of the video. Let's start with remembering what an inverse of a linear function is. Remember that inverse is when we switch our x and y, or it's a reflection over that y equals x line. So there's y equals x, our parent linear function. So our graph should be reflected over this line. And the way we solve it with the linear function is if this was f of x, we would change it to y, but they've already done this for us. Then we switch our x and y, and then we solve for the new y. So I'd subtract my 3, then multiply everything by 2, and I get 2x minus 6 equals y. So my inverse of the original was 2x minus 6. And if I graph the original on here, I should be able to see that they're inverses, that they reflect over this parent linear function. So there's the original. Here's the inverse. And you can see that they are images, mirror images over that line. So if I were to fold it in half right here, I'd get the same line. So this is how we found inverse of linear functions. It's going to be similar with the radical functions. So just to go ahead and start out with, the inverse of a radical function is a quadratic. So you should get an x squared in your answer. So if we follow the same steps as linear, change f of x to y. So now I have y equals the square root of x minus 2 plus 3. Then we switch our x and y. So now I have x equals the square root of y minus 2 plus 3. Now I'm going to solve for my y. This is where it gets a little tricky because I have that radical. I'm still going to subtract my 3 from both sides. And then I have to get rid of this radical. So the inverse of a square root is to square it. So we'll square both sides. And over here I just have y minus 2. I can leave it as x minus 3 squared, or if you can expand it, put x minus 3 and FOIL it. But this is easier, it just keeps your quadratic in vertex form. So then I add the 2 over, plus 2 equals y. Then we change y to f of negative 1x. So I've got the inverse of that function is x minus 3 squared plus 2. And this is fine to leave it in vertex form. It makes it easier to find your vertex. Alright, so let's graph our original and then our inverse to make sure that they're inverses of each other, which means that they reflect over this y equals x line. So I have got a vertex at 2, 3. So here's my radical. Right there. And then let's graph this. This is a quadratic. I have a vertex at positive 3, positive 2. And I can use my pattern to graph. Alright, so looking at our original and then looking at our quadratic, our inverse, they're supposed to be mirror image reflections of each other, but they aren't. Okay, that's because you're going to need a restriction. And that means that the entire quadratic is not the inverse of your original. You can see here's my original. The right side of the quadratic actually is a nice inverse. It's the left side that doesn't work. So what we want to do is restrict it, so that way this piece is not part of my inverse. So we only want this right side. And that's what you do for that, is you get a domain. We make a restriction by saying that the inverse of this radical function is this, but only at a certain domain, only from here to infinity. So there's a couple ways to do that. You can look at this and you can see this is at 3. So from 3 to infinity, that would be the domain that we want. Another way that helps, you could also write it as x greater than or equal to 3, depending on the notation you want. But another thing that helps is before you take the inverse, I would take the original, write your domain and your range. So this domain is 2 to infinity, this range is 3 to infinity. Because we switch our x and y when you do inverse, the inverse has a domain of 3 to infinity and a range of 2 to infinity. So all that happened between the domain and range is they switched. So the domain became the range, and the range of the original became the domain of the inverse. So you could find if your inverse is here, then it's restricted to this domain right here. So what I just boxed is your official answer for the inverse of square root of x minus 2 plus 3. So if you just leave it like this and you don't put a domain, it would be wrong. A correct inverse of a radical always is a quadratic with a specific domain. And again, if you don't want to read it on the graph or you don't have a calculator, you can't see it and it's hard, just find the range of your original, and that's the domain of your restricted inverse. So let's try that again. That was a lot of information. Let's go ahead and do it again. So we'll change f of x to y, just following the steps from the other slide. Switch x and y. Then we solve for x. The only way to get rid of a square root is to square it. So I have x squared equals y plus 4. And then I subtract the 4. Change your y to f of negative 1x. Okay, so this is the inverse, but again, if you leave it like this, it's wrong, because the inverse of a radical is only half of a quadratic, not the entire parabola. So I can come back up here. My domain here is negative 4 to infinity, and my range was 0 to infinity. So that means the domain of my new inverse is 0 to infinity. My range switched to negative 4 into infinity. But my answer just needs to be this. So the inverse of radical x plus 4 is x squared minus 4 with a restricted domain of 0 to infinity. So now if we graph the original and the inverse with its new restriction, you should be able to see that that it reflects over that y equals x axis. Y equals x line. Sorry. So here's the original. Like that, something like that. And there's my inverse, minus 4. But this time I'm only going to draw from 0 to infinity. So the parabola is this entire thing, but I only want it to exist from 0 to infinity. So it's just the right side of the parabola. So now you can see that the original has an inverse. That's a quadratic, but only half of it. So then this all is the correct way that we want you to solve for an inverse. Okay, before we prove inverses, let's talk about what it's like if you have a quadratic and you want to take the inverse of that. So we know the inverse of a quadratic must be a radical, because the inverse of a radical is a quadratic. But let's look at that restriction here. There's no domain or range in this example. So it's telling you the entire parabola. If they gave you a domain, then that would be different. But because we want the inverse of the whole parabola, we'll go ahead and switch our x and y. We'll add the 6. and then we'll take the square root. That's how you get rid of a square. And this is where your plus or minus what we did before has to come into play. So when you have to draw a square root, you can't forget the plus or minus in front of it. Okay, so this is how a parabola, 1, 2, 3, right here. Let me see if I can draw this here. This is how a parabola has an inverse of a radical, because it's the positive x plus 6. So like this. And the negative of x plus 6, square root of x plus 6. Remember, the negative just means it reflects it. Right, so there's a parabola, there's a reflected parabola. If you don't forget the plus or minus, then you're only telling me that it's just one piece, which doesn't make sense. A parabola is a different shape than a radical. So you have to remember that plus or minus. Okay, so that means the inverse of x squared minus 6 is both positive radical x plus 6 and negative radical x plus 6. So one that looks like this and one that's reflected. So it's a full parabola. So just be careful on that rule. Whenever you have to draw a square root, there should be a plus or minus there. So if you remember from linear functions, when we did inverses, we proved them by composing the functions and the inverse together and then simplifying it. If they equal x, then you have an inverse. So let's start by plugging the inverse into the x of the original. So that's f. And instead of plugging in x now, we're going to plug in this function, which is f of negative 1. All right, so I'm taking this entire function and I'm plugging it in for the x of the original. So instead of x, I have x minus 3 squared plus 2. And then I go back and I have a minus 2 still, and I have a plus 3 on the outside. So I just replaced my x with my inverse. Now I'm going to simplify. If I get x, then these are definitely for sure inverses. So I can simplify first by doing these. Plus 2 minus 2, they're just 0, right? And then the square root of something squared, the square root and the square are inverse operations, so then it just becomes x minus 3. I still have this plus 3 out here. And so that becomes x. So that proves that this function and its inverses are for sure inverses. All right, there was a lot of information in this video. There were 4 questions, so don't forget to go back and answer all of your essential questions in the summary. Your grade for this notes comes from your summary, okay? So make sure you answer them all. If you didn't understand any part of the video, go back and watch it. All right, that's it for now. Thanks for watching. Bye.